We're given 4 vertices of a quadrilateral, and we want to figure out several things about it. First of all, we want to sketch a picture of it so we have kind of an idea of what it's going to look like. What are all the side names? We then need to calculate the side lengths and the slopes. So the first thing is, let's draw a sketch. So the first point is H, which is at -2, 1. That would be right here. The next point is at 6, -1. That would be here, and that is point T. A is at 3, 4. That's up here. And E is at 1, -4. It's really important to draw a sketch because if I had connected these points in the order that they were given to me, I would do H to T to A and then to E. That doesn't make a quadrilateral. So it's really very important that you make a sketch of the points so that you can see which points actually form the quadrilateral and in what order. So I'm going to connect these in the order that makes sense so that they make a quadrilateral. The sketch also helps you to see if your answers are reasonable. Just by looking at this sketch, this kind of looks like a square that got tilted. So I wouldn't be surprised if we came out that the side lengths were all the same and that the slopes were opposite reciprocals, because those are the two characteristics of a square. All right, so let's talk about the side names. There are 4 of them. I'm going to start with AT. The next one I would say would be TE. Then EH, and finally HA. And this one turned orange on me. Okay, so I have to now find the side lengths of all 4 sides. So I want to remind you of what the formula is that we're going to use for that, and that is the distance formula. So I'm going to write that up here. Distance formula is x2 minus x1 squared plus y2 minus y1 squared, and it's the square root of all that. When we look at our side lengths, we are going to have to reduce any radicals if that's necessary. All right, so let's take a look here. A and T, I'm going to label them up here. So I'm just going to say that this is x1, y1, x2, y2. And I am going to set up my distance formula so that all I have to do is plug in my numbers. So x2 minus x1 would be 3 minus 6. And then y2 minus y1 would be 4 minus -1. Now at this point, I would say you would want to put everything that's under the radical in your calculator and figure out what that number is. So when I do that in my calculator, I come out with 34. So this turns into the square root of 34. 34 you could break down into 2 times 17, but there won't be any pairs, so we don't need to do any breaking down. So I'm going to label that on my picture, square root 34. All right, now let's take a look at TE. So I'm going to erase the labels that I had before because those we used for AT. Okay, so T and E, I'm going to label x1, y1, x2, y2. I'm going to set up my distance formula, and now we just have to plug in numbers. x2 minus x1 is 1 minus 6, and then y2 minus y1 is -4 minus -1. So again, you're going to put this into your calculator, and you're just putting in the part that's under the radical. You're not actually putting in the radical. And we should get 34 again. So now I know that TE is also the square root of 34. So earlier I said this looks kind of like a square, and so far that's checking out. It seems like all these sides are going to be the same length, but we have to check. So I'm going to set up my distance formula, and I'm going to erase my pink labels, and I'm going to put in green numbers on the points E and H. So I'm going to make this x1, y1, and then x2, y2. And remember, it doesn't matter which point is the 1s and which point is the 2s. So for my distance formula, I would have 1 minus -2 for my x's, and then -4 minus 1 for my y's. So now we're going to plug this into our calculators again, just the part that's under the radical. And when we do that, we get 34 again. So HE is the square root of 34, and my prediction is that HA will also be the square root of 34. So I'm going to erase my green labels now, and I'm going to label H as my 1s and A as my 2s. So this would be 3 minus negative 2 and 4 minus 1. And when you put that into your calculator, you should get 34 again. So that means that HA is also the square root of 34. So at this point, I can say that this is either a square or it could possibly be a rhombus. And the way that you tell the difference is by looking at their slopes. If their slopes are opposite reciprocals, that means that they're perpendicular. That means you have right angles, so it's a square. And if their slopes are not opposite reciprocals, then it's a rhombus, because that does not have to have right angles. So the slope formula looks like this: y2 minus y1 over x2 minus x1. So we can go through and figure out the slopes for each of these. So for the slope of AT, I'm going to go back and I'm going to relabel my points. So I'm going to say that A is, well, let's do T is x1, y1, and then A can be x2, y2. All right, so for the numerator of my fraction here, it would be 4 minus negative 1. And then x2 minus x1 would be 3 minus 6. Now we have to do a little bit of simplifying here. 4 minus negative 1 is 5, and 3 minus 6 is negative 3. So this is our final answer. Usually you'll see it written with either the negative out in front or with the 5. But either way, negative 5 over 3, that would be our slope. Now let's take a look at TE. So I'm again going to go back up here and I'm going to relabel. So I'm going to make this x1, y1, x2, y2. Okay, so for the slope of TE, we would have negative 4 minus negative 1 over 1 minus 6. So that would give me negative 3 over negative 5, so that would be positive 3 over 5. Now, just by looking at our first two slopes, they are opposite reciprocals. They're opposite signs, and if you take one of the fractions and flip it, it becomes the other fraction. So my guess is that the others are going to be the same, but we do have to double check. One other thing that I wanted to show you that is hopefully going to make our lives a little bit easier is you might notice that in the distance formula, y2 minus y1 is your second set of parentheses. That's the same thing that's on the top of your slope function, or your slope equation. So if you look here, 4 minus negative 1 is here and here. And that's not a coincidence. That will always happen that way. And then same thing, 3 minus 6 is x2 minus x1. That's the same as the denominator of your slope formula. So for these next two, I want to do like kind of a shortcut. Since we already went through all the work of labeling everything, we can just go straight to taking the second parentheses, so negative 4 minus 1, so this one right here, and then dividing it by this one, so 1 minus negative 2. So that would be negative 5 over 3, and that one is done. And then we'll do the same thing with our last one, which is for the slope of HA. I would take my second parentheses, 4 minus 1, over my first parentheses, 3 minus negative 2. And that would be 3 over 5, because this is really 3 plus 2. All right, so now I can take a look at my slopes, and I see that they are all opposite reciprocals. So what that means is that my final answer, and it got cut off on the bottom here so you can't see it, but it says this quadrilateral is, and in that first blank you would write a square. And the reason is because the sides, it has 4 congruent sides and perpendicular slopes.